Welcome back. So let's try to take another look at this bytecode compiler that we're working on. And I think we're gonna add something else to our chunk, which is gonna be line information. In case there's an error when we execute the code, it would be nice for the user to know that. And for that purpose, we need some kind of way of storing, like if an error happened at this byte, which was the corresponding line in the source code. So one way you could do it is just let's line info, or let's call a line number, and it is also kind of an array like this. However, maybe we can do it a little bit better by using a hash map. So let's actually make that. Let's call it, I think you do like this. So it should be a map from an index, basically. So I guess we write int and to an int. So the first one is the byte index, and the second one is the line number. Let's see if it runs. It does run, so that seems to be correct. Now we should remember that when we delete the chunk, we also need to delete, and we call it line numbers instead. I think that makes more sense. Let's see if that runs. It also runs. So now basically when we add something, we need to add a line number as well. And I guess also as well here. So when we add this operation, we'll also add the line number. And then down here in add operation, we'll say line number. And by the way, let's remove Copilot. Line numbers at the current. So something like this. For this bytecode instruction, it should be this line number. Let's see if it runs. It doesn't run because now there's a problem in main. So down here in main, we're adding stuff. And we can just say this is line 1, line 2, line 3, and line 4. Still, I forgot to say chunk dot and mode alloc non-zero not supported. Interesting. So when you make what is alloc non-zero? Anyway, I guess whatever it is, we just should support it over here in our allocator. And we're going to do something quite similar to this guy. Add another case. Alloc non-zeroed. And yeah, same thing. So now it works. And let's now include this line information in the chunk when we do this disassembling. So basically, every time we write something, I want to write where that comes from, which line it comes from. So let me add a couple of comments. So like write opcode, handle specific opcodes that have operands, let's say. All right. But then basically we want to say we want to do something like we concatenate to the output something. And what are we going to put? Well, we can put the line number like so. And what do we need here? We need basically the index, like that byte. And now what will happen if we do that? So here we also have the down here we have the constant value. Let's try to run it, see what happens. So it's gonna look quite weird. It's gonna look like this. And actually maybe I want to do something like this and then write line. So now we can see kind of how it looks. And this guy I want at the very end. And now we have, let's do some kind of like padding. And we will say I am not sure how to make a string in a good way. So there is a function called writeJustify, which returns a string. So let's say output equals strings.writeJustify, and it takes the string, the length, which for now we can say 25, and a padding, which is just a space, and an allocator we don't need. So let's try to run that. It failed. Let's fail to do anything. Let's try to do that. Again, it failed. It seems it's doing something to the first line. It's only doing something on the first line. And I guess that's because we need like a temp string. And then it's the temp string that we're actually adding to in here. And let me just do this. And then at the very end we need to say output equals strings.concatenate. Not that, but temp. Let's try that. So now it's at least doing something. We just have a final problem, which is that at the very end we need to clear that out. Is there something? Remove all the key string in the S string. Don't know what that means. Okay, you know what? We're just gonna do like this and let's see how well it works. So it's not doing the right thing. I guess we need left justify. And now it's correct. So now if we put it at a more reasonable number, it will do something like this. Now, unfortunately, it's because it's saying 0 all the time, because why? Line numbers, length of chunk code, that should be because we need to call that one after, otherwise it doesn't work. That's a bit of no, still doesn't work, and it thinks that return is so add constant. We put a constant in the constant place. We append, so that's obviously a problem. We actually have to add it first. So we add the constant, and then we put in we have the constant like opcode, and then we put in the data for the constant. Then when we add an opcode here, we append it to the code, and then this should be all right. I guess there's a problem here. There we go. And not even the first one is correct. Maybe we should say instruction counter. So something weird is happening. Let's change this to index. Let's get this out and let's call it line number. And we'll put it in here. Except that this can also return an error, I think. So let's say if error. Let's just print a line, error. And we do get an error, get one error. So let's print the index at number 6. But all the other ones seem to fail as well. Let's try the following. Let's say adding line number to, let's call it address. Okay, so it's correct enough. Address 0246. Happy with that. Getting line number for index. So somehow it's offset, and why is that? It's because we are calling it after this. So actually we have to, it's a pretty annoying bug, we have to get the line number here. We can move this back up. Probably there's a better way to structure this. Let's try to run it now. Now it's just 1, 2, 3, 4. Let's remove this guy. And there we go. The last thing I want to do actually is to try to use something called a panic allocator. It will just panic, and there should be panic allocator. There should be a method for making that. So I want to say context, let's say old allocator. Well, this, I don't know. Okay, context.allocator is equal to, I think we need, now what is it we need? It is map, okay. So anyway, we get a panic allocator. And now if there's any allocations in here, it should fail. So it does do that, which is fine, I guess. Let me try something else. Let's see how many allocations there are. If it's resizing, it should also, and this one, I guess. So we're gonna write entering disassemble. And then down here we're gonna write exiting. Because now we can run it and we can say for some, okay, there we go. So it's doing a ton of allocations. And let's actually alloc not zeroed, resize, and allocating. Let's run that. So it's really only doing allocations, and there is no free. So what I'm wondering is, do we need to say delete, defer free output? No, it's supposed to return the output. But how about the temp? So let's try to free that. That didn't work. Do we need to delete it? So it didn't log that, but we can log it. Still, it doesn't do anything. I think if I remove it, it still will have 4 frees. Interesting. I'm not really sure what happens with these strings. So I will have to look into that. I'm guessing they're just on the stack somehow, but then I don't know how this works exactly. Anyway, I'm gonna remove these locking statements. And now, when we run it, it will just disassemble and it will give us line information. So that's great. And I think that's it for this video. So I'll see you in the next one.